IoT and sensor embedded IoT driving smart technology. This is the second day of this program. This prestigious gathering brings together visionary minds to explore the transformative potential of the Internet of Things, sensor integrated system, and intelligent technology that are shaping the future of smart cities, sustainable infrastructure, advanced communication network, and digital innovation. We are honored to have your presence today as we collectively discuss emerging trends shaping cutting-edge research and foster meaningful collaborations that will drive India's technological growth in the coming decades. In today, there is a keynote speaker with us, Brigadier Adarsh Bharadwaj ji. He is a retired army man and he is the Executive Director, Agista Industry Private Limited. So welcome, sir. We welcome you. And Professor Pradeep Dimdi sir will give the sampling to him for the just token of gratitude. Sir has a vast experience in field of defense as well as in technology. He is the alumni of Sir J.C. Bose University of Science and Technology YMCA in batch of 1983 and Army veteran with 34 years of varied experience in the military operations, technology, logistics and administrative domains. He is the MTech in optoelectronics, MBA and has done prestigious higher defense management course. He has been part of Op Prakasam, Op Kargil and counter insurgery operations. On staff appointments side has been Chief Engineer of Indian Army Armament Domain and also headed Army Technology Cell, now transformed as a Army Design Bureau. He has worked with the Defense Intelligence Agency and Integrated Defense Headquarters. He as Defense Space Technology Domain Analyst has been a valuable advisor and mentor to the Indian space ecosystem in pursuing strategies. And he is a project and also active contributor and member in Defense Space think tank focus and association like the Indian Space Association, National Advisory Board and Center for the Joint Warfare Study from Forum. So welcome sir. Second, Professor Neelam Turk madam is also with us. He is the session chair of this session. So Pradeep sir, again I am requesting you kindly give some token of gratitude to ma'am also.
आपके लिए भी थोड़ा सा रहेगा, ठीक है।
Professor Neelam Turk Madam received BE degree in Electronics Engineering from the North Maharashtra University, Jalgaon in 1998. She did her MTech in Electronics and Communication Engineering from the NIT Kurukshetra in 2002. She received PhD degree in Electrical Engineering from NIT Kurukshetra in 2011. Currently, she is working as a professor and chairperson of Electronics Engineering Department with the J.C. Bose University of Science, Faridabad. She has teaching experience of more than 20 years Her research interests including MCSA, signal processing, speech processing, wireless communication, wireless sensor network, and many other subjects also. She has published more than 55 papers in international journal and conferences. So now, with these words, I would like to start today's session. So, sir, I invite you kindly join the session and give the strong knowledge regarding the army, defense and technology to us. Thank you, sir. Please come.
Yeah, so full screen कर देना. Will be controlling from there only, no? Will control from there only.
Yeah. And this is the pointer. You can use it.
Plus minus.
Yeah.
Forward and.
It is now. It is on.
Thank you. Good morning, everyone, and Jai Hind. Firstly, I am delighted to be part of this 40th National Convention of Electronics and Telecommunication Engineers of National Conference today, and with the permission of Vice President IE, and I would like to start my talk on this subject on this. As briefed already, I am the alumni of this institution. I was part of the system for 4 years, and I know the campus in and out, and what are the things were there earlier, and now what are the changes that happened in this kind of institution. And just to add on to the students, in fact, not only me, and my son is also a graduate of this institution. He passed out in 2010. He's from mechanical stream. Basically, I am from mechanical stream. I am not so professional in electronics and telecommunication, this thing, but my aim to address the young students, young minds, because some of them, you are writing papers, doing some kind of research work on the various subjects, and just to generate the interest, what kind of domains are there. I will keep my address slightly different than whatever you have heard yesterday, or you are going to listen now today also in too much of technical topic, research papers. Because as I mentioned to you, I am not from electronic stream, but definitely I will like to communicate what is the importance of this domain, that is this IoT and sensor enabled IoT framework, and how it can be leveraged for the overall growth of the country in this. So now with this, I have structured this presentation in some kind of semi-formal type of approach, because since I have mentioned to you, I am not professional. I'll read some of the things which give you what kind of importance it has got and how it can be taken forward on this. And basic, as I read it again, aim is just to make aware the young students, young engineers, what all they can contribute. Since I am from the security background, defense background, my thrust will be more on that the security aspects. What are the things? For example, IoT, sensor-enabled IoTs. You can create a foundation, but foundation is laid by brick. So each facet is important. Each research, each domain is important. So, but how to create a complete structure so resilient and you can say foolproof, that you should keep in mind always, wherever you are working, whether you are working in the industry, whether you are working in academia or anywhere. So you should keep in mind. So I'll whatever things I'll tell you, I'll go in point forms. Now it is up to the young generation how you pick up those points, you analyze those points and apply in whatever area of research, whatever area of studies you are doing it on this. I am thankful to this Professor Dimbri for inviting me and to be part of this event. As this theme is in line with the Atmanirbhar Bharat and India Digital Initiative, this invites positioning IoT as a critical facet of technological self-reliance, researchers and policymakers to explore IoT's vast potential while addressing critical challenges like robust architect, scalability, cybersecurity and economy of scales. Yesterday, I was going through the complete itinerary, what kind of things have happened yesterday's event. So I believe there was some discussion or some kind of presentation on healthcare related to and with the IoTs, what are breakthroughs in that, lightweight of IoT driven image encryption using AES, smart energy management, designing efficient multiplier architectures, 2 UAV system for post-disaster reconnaissance, ethical, regulatory and interoperability, and IoT-enabled smart building. Those kind of relevant papers were there, very, very important. And some of the topics which were related to security, I don't know like how many were there present when those were presented. And my main stress is on those kind of topics. Firstly, like blockchain integrated cybersecurity architect for protecting sensor-based IoT networks, IoT security based on asymmetric encryption techniques. These kind of topics, they are highly relevant for the security of a complete system. So why I am giving more stress on this, as I mentioned to you, my aim is to just generate where is the national security facet and national security things come to mind. What as a technician, what all things you should keep in mind on this. What is the context? What is the national imperative of this? Why we are here? What we want to discuss? What is the aim and objective of this? We should know the complete background. What is the overall context and what are the overall directions of the government of the day and what they want to progress, how they want to do it on this. India is entering a critical decade of digital transformation. The Internet of Things, complemented by advanced sensing technologies, is emerging as a nation shaping capability. IoT enables machines, devices, infrastructure and environments to exchange information seamlessly. We all know it. Sensor-enabled IoT shifts from simple data capture to the context awareness. It empowers technologies to sense, analyze, act, enabling sustainable growth in urban management, healthcare, agriculture, industrial production, supply chain, and national security domain. We have heard about Digital India, Smart City missions, Make in India, and Atmanirbhar Bharat. Just keep all this mission in this mind. Complete thing, whether it is your electronic domain, mechanical domain, atomic domain, space domain, everything revolves around all these kind of mission statements. Basically, we know it. The strategic relevance of this topic is concerning the urban transformation, how IoT can be used for urban requirements, industrial competitiveness, healthcare, and your agriculture. We all know it on this. Coming on to the security imperatives. Before I start my presentation, this IoT introduced unprecedented attacks on surfaces because the kind of devices, kind of patching, kind of compatibility are doing it. What are these surfaces where which are vulnerable? These are sensors, gateways, wireless links, and cloud endpoints. So whatever we do, then we should keep in mind, whatever we design, whatever we work, we should have zero trust architecture. Device identity rooted in hardware security. You must able to identify what kind of device you are using it. And end-to-end encryption. This is the requirement, especially in the security and defense domain. Then edge-first authentication. That is another important factor. Domestic firmware and trusted supply chains. CERT-aligned compliance and frameworks. So these are some of the security imperatives. As a professional in electronics and technology domain, we should keep in mind while we are using this kind of technology for this. I will not get into much about this AI and IoT conversion. Young generation is aware of what is the use of AI if we couple with this IoT capabilities. I have made small presentation just to give you idea with some kind of examples how this IoT sensor enabled IoT and with the help of AI is being used in the defense and security scenarios on this. Next, please. As I mentioned, there are three key factors you must keep in mind: Digital India, Make in India, Atmanirbhar Bharat. Especially Atmanirbhar Bharat in terms of technology and strategic autonomy. You all know it. Till the time we are self-reliant, and till the time we are not self-reliant and we are dependent on others, so we cannot achieve the same. Generally, nowadays we use for indigenous solutions, various things, indigenization. So my advice is, so rather than going for indigenization, as a professionals, now we should use word indigenous solutions. Indigenization gives you some kind of feeling, whether I think you are replicating it, you are trying to copying it, you are trying to do reverse engineering and make in India. Better could be as a professional to use word indigenous solutions, indigenous developments. So if you aim that, then you can achieve this technological and strategic autonomy in the country on this. Next. Now, IoT in defense. How it is used? It is a general picture. Very, very generic picture. If you see, it gives rapid integration of digital technologies in redefining modern warfare. Earlier, we used to fight with the swords and various other things. Things changed, came into normal rifles, your machine guns, heavy machine guns, you can say artillery system, tanks, aircraft, fighters, warplanes. Now things are changing, evolving globally. So this is an area where everybody is dependent on now. Whether USA, Europe, Russia, China, India. Unless we are into this, we cannot safeguard our national interest. So these are the very, very important things you must see. So second bullet, especially IoT is not a convenience. It is a requirement, necessity, and it is a force multiplier. Where we can use it? The land, air, sea, cyber, space. Earlier we used to talk about Army, Navy, Air Force. That's all. Now it is a cyber and space also. So everywhere this IoT and IoT enabled, you can say sensors, embedded sensors are used in these kind of systems. What for? Generally, we want to use it for surveillance, reconnaissance, and execution of operations on this. Now, Internet of Battle things. What is the difference between civilian approach and defense approach? You can see that civilian IoT is basically designed for convenience and for connectivity in a stable environment, like peace environment. Whatever we do, it is for the stable environments. Our focus is on data collection and use it for connectivity and other various application gadgets, things. Whereas military Internet of Battle things, it operates under existential threat, where there is a question of life and death. Those kind of scenario. That is kind of background this military IOBT operates. The objective is to basically make you aware how building networks that are not just connected but secure, resilient and intelligent to ensure mission success. So that is a prime mission or objective of any military domain related to the sensors and this Internet of Things. Next. Intelligent collaboration. You can go through that slide. Future battlefield. Get back. Future battlefield and present battlefield. What kind of thing you can expect? A hyper collaborative ecosystem of man and machine, only if we say only man can fight, no. If only machine can do, no. It has to be collaborative effort. It can be mix and proper compatibility between man and machine. So that is a first point. Second is scale. Multitudes of sensors, weapons, vehicles, satellite communication instantly. It is a very, very vast subject. It's not so simple. Whatever we see in movies, whatever we see in war movies, we understand, okay, this is action point. How it has happened, what kind of forces are behind, what kind of technology is behind, so that we are able to achieve those kind of things, those kind of actions you see visualize on that. Those are virtuals. But you need to visualize, or we need to analyze on those things. The goal is seamless collaboration between war fighters and autonomous systems, because everything we can't depend on autonomous systems, because there has to be somebody to analyze and decide. So automation is a need of the hour, but it has to be have some kind of limitations overridden by the human intervention on this. Now, I would like to share with you, with the young generation especially, what kind of doctrine, what kind of philosophy we follow in the defense forces. Sensor fusion, data-driven operations. You try to analyze each word and meaning of that. Sensor fusion, data-driven operation and autonomous system will be the backbone of future-ready combat teams. Another one, the battlefield is shifting to a networked, multi-domain information environment where IoT devices forms the first layer of tactical awareness. So each line, each word carries the meaning where you need to analyze, where professionals can think how they can contribute to empower India on this. Next. Now I'll give you some examples. This IoT as a battlefield enabler. Next. Basically, it is all sensors are generally various types, but generally are unattended sensors which they are supposed to perform a particular task. They do that. So they are deployed on the locations where they're supposed to be. Operational requirement is there, where the infiltration routes are there, some kind of border areas are there, and they are not only deployed in the land, they are deployed in the sea also, they are deployed in the space also, those kind of sensors on this. And they form the autonomous grid, whether it can be part of seismic, acoustic, infrared sensors. So different sensors have got different tasks and capability, but they need to talk to each other, they need to transfer data with each other, it needs to be compatible in a grid system on this. And all this provides a persistent unmanned surveillance layer on that. And to use this kind of sensor, then you have the integrated command and control centers where raw data sensors and data is mixed or used with the GIS maps and other things, because unless you correlate on ground what it is giving and for what which purpose is giving, which location it is giving, how it can be used, it is of no use. It is a waste of data on this. Then how it helps? It enables commanders to monitor terrain and threats in real time and transform raw data into actionable intelligence. So that is the crux of the sequence where this IoT based sensors and AI, supported by AI, helps in kind of decision making, and where we take some kind of decision to go in for that operation or how to execute, those kind of things comes up in that. Next. One example, the smart fencing. You must have heard in the news or you must have read in the papers, like we are going digitally to fence all around this border area, whatever we are having this with adversity with Pakistan and especially with Bangladesh now. So this is an example of this smart fence. This is a comprehensive integrated border management system. It has got thermal imager, it has got IR sensor, acoustic sensors, seismic sensors, various kind of sensors are integrated into systems. So whenever there is any intrusion is there, that is detected and passed on to the command control centers, and the accordingly action can be taken place on this. And impact is this kind of grid, this IoT grid, it gives you 24/7 autonomous surveillance system capability to that, which is humanly impossible otherwise. So everything is assisting human efforts on this. Next. important thing. Man is the ultimate thing. Whether you take it in industry, corporate, defense. Unless man is empowered, unless he's got force multiplication capabilities, he cannot perform. It has to match with the global context and what kind of technological advancements are happening in this. So nowadays, soldiers are not simple. All their gadgets are also very, very highly, you can say, you can say latest trends in technologies, whatever is there. Like you can say your body cameras, your sensors, your communication networks, everything is embedded, and again these are the system of sensors embedded in the particular suit of a soldier that gives him those kind of empowerment to decide and act accordingly whenever he is in isolation or part of any team in this. Next. Everybody knows about drones. You must have seen the drone shows. Okay, multiple drone shows in numbers, hundreds and thousands. They work with each other. The drones talk to each other whenever they're in the flight, and they attain a particular shape. Okay, you have seen the figures like various shows in Delhi or other areas in Varanasi. These were there. So what is there? It's the same thing. Whatever you're doing, it same domain, but application is different. Basically, it is a large scale. Drones are required for a particular task, whether it can be for civilian task, some kind of, you can say, surveillance in the forest areas or something in a grid pattern, or primarily they are designed for the military applications. Swarm drones, this is the concept. What is that? It is mesh, a network only. It is the same. Sensors are talking to each other. They are embedded on that. The data is controlled, analyzed, and given the direction accordingly. So these are the live examples of how we are using this kind of technology in this domain only. All these things basically is being used worldwide, and now we are, you can say, I can tell you, I can share with you, we are not second to none. We are almost at par with our technologies. Yes, though there are some technological gaps in terms of some kind of sensors, some kind of your semiconductors, which our government is pushing for that those development. Once those things are available, so we will be able to match other things also. Another grey area which I want to share with the young professionals and the students, like, is the material domain. That is which area where we need lot of research, lot of you can say investment and drive from the government also. That needs to be addressed. R&D efforts has to be put in on those kind of things. It is a very, very critical aspect. Next. So, to sum up on this, edge intelligence as part of battlefield IoT, it is beyond connectivity, actionable intelligence, and key domains. If you see key domains as part of security parlance is concerned, space to ground satellites and soldier as system. I have given you example of that. So these are the basic facets of this mostly sensor driven systems. Next. Since I am working in the space domain for last 5 years, so I will touch upon this, what kind of this technological aspect is infused in the space domain, because main sensor, you can say your intelligence, your surveillance and reconnaissance happens from the space nowadays. So you must have heard, like US got a capability, whatever assets they have in space, like satellites, they can recognize individuals on ground. Who's that? Even they can read the text. If some book is lying in the open, if the satellite zooms on that satellites can read what is written on that book. So that kind of sub-meter resolution kind of satellite is this. And everybody knows it. Satellite has got various applications, communications, remote sensing, and weather forecasting, defense applications. Those are the area where everywhere the some form this sensor enabled and IoT grid is functioning. and making the user empowered on this. Next. The space I mentioned to you, this is the ultimate census. So most of the things which is being done in this field is from the space. Low Earth orbit constellations. Earlier you must have heard geo-orbit constellations, low Earth orbit constellations are there, and they are critical. The Internet of Space things is a mesh network, like drones, the multiple drones, they talk to each other. There are multiple satellites also in constellation. Satellite constellation can be 2 satellites, can be 10 satellites, 100 satellites, or 1,000 satellites. Like Elon Musk and all these things, whatever communication system they have, the grid they have the hundreds of satellites. And the kind of data fusion and kind of linkage in between the satellites, all this through with the, you can say, sensor-enabled IoT systems on this. This persistent surveillance, the revisit time reduced from days to minutes. Why? I'm saying, let's say one satellite is in the orbit, it is revolving around Earth. So it takes some time. Let's say, for example, at YMCA, if you want to image something, the same satellite may come after 6 days. So what is the outcome? Then you have multiple satellites, number of satellites. That's it, I use word hundreds of satellites. So satellites come one after each other. Even let's say satellite first satellite who has taken the picture of this institution goes away from the ground station, because first satellite is picking up the imagery, but that is the data. But you need to download the data. Unless there is a ground station, you cannot download the data. Once first satellite pass over from that particular ground station, we'll wait for 6 days. No. Satellites are talking to each other. There are inter-satellite links. Those use this kind of facilities. So there is a very, very fast revisit, very, very fast, you can say, real-time information. You get it based on the number of mesh networks and number of constellation of satellites. Creates an unprecedented multi-layered picture of battle space. So I am using in the defense domain. It gives you complete picture what's happening in this. Next. Sindoor. May this year, everybody knows about this. Okay. Whatever you have seen on TV and media, the same thing. All the UAVs, everything, they use all Internet of drones, all complete technology was used in this and applied in this. And you can read the last line in the red, proved military grade IoT is battle ready. That kind of technology capability we have in India, but it is not a fixed solution, because these are dynamic in nature. Upgrade happens, keep on happenings in that. We need to match up. So we need to do research and analysis in those kind of areas regularly. This command control and communication integration, basically again it's for the, you can say, radars and UAVs. You must have heard the terminologies during the Sindoor, how we picked up the targets and how we how we could be able to integrate the UAVs, aircrafts and your missile systems. So everything is autonomous based on the sensors, but definitely yes, they are decision makers. Once this AI based system gives you some kind of options, then it is up to the military commander to decide or analyze and corroborate and again decide on that, they act on this. So I can say during our program, this kind of grid system was very, very helpful. Next. Command and control. The command control enables instant dissemination of targeting from whatever the sensors you have. Resilience. Basically, this is a word as a professional you should keep in mind. Unless your system is resilient enough, it cannot be applied with kind of confidence on this. Autonomy, like for example, SON drones continuous mission based locally processed data if command is cut. It is not like that. If I am particularly having the command of a system, your system should have some kind of autonomous also. Let's say, okay, enemy jams it, they are using jammers, they are cutting off the signals, then this grid can function in autonomous way also with the help of pre-fed command and controls. Next. when we talk about ourselves, we need to talk about others also. Unless we know our strength and weaknesses, we cannot progress or we cannot proceed. So we need to analyze what our adversary has done, where we were lacking. Yes, definitely. There were some plus points because Pakistanis were backed up by Chinese technologies. They had a slightly upper hand, but we could act and react in time, so we could achieve those kind of success on this. But there are certain takeaways. Okay, where are technological gaps on this kind of things, we must come over those kind of things and encounter and should be able to give better solutions on this. Next. Speed, accountability and trust. These are the keywords whether you use this kind of technology systems in civil domain, anywhere, whether industrial application, transportation, logistic management, hospitals, agriculture. So everywhere these kind of thing has to be there. Human on the loop. I mentioned to you, you can't leave everything on the machines. Ultimately, you have to decide. If you are the commander, if you are the you can say CEO of a company, you have to decide. Okay? Whatever autonomous may take place, whatever sensor enabled, you can say TOT, IoT or AI based solution you have, but this is a very, very crucial facet. Everybody should note on this. And of course, explainable artificial intelligence. Artificial intelligence has got pros and cons. It may be biased. It may have certain kind of bugs. It may give you some kind of wrong data. It may have wrong comparisons. So you got to be careful as far as using of this. And audit trials, of course, there has to be feedback loops. Wherever the gap, you need to identify and evaluate and improve accordingly. Next. Security imperative. In simple terms, you can go through that. IoT introduced, I have mentioned to you, because there are multiple surfaces, multiple areas where you can get the cyber attacks and other things. I will not read it again because I have already in my text I have conveyed to you these points, but these are the very, very important things. In the last, I will give you around 8 to 10 critical points, security points. As a technical and professional, you must keep those points in mind while designing or developing these kind of sensor systems. Next. This is something like which academia industry can note, how we can develop, where are the gaps, how we can do that, because these are the sensors fabrication MEMS, embedded system design and firmware, semiconductor architecture, edge AI hardware accelerators, low power communication protocols, indigenous encryption modules. So these are the areas we should have more stress. There is a gap in technology as far as our country is concerned on this. And how does the role of academia industry comes up on this? What they can do? They can provide IoT test beds, national standards which are very much required, university center of excellences, that is where this institution like YMCA can pitch in. They can have those kind of center of excellence, defense industrial partnership, and dual use innovation pipelines. So that is the crux of every technology. If you read any management book or if you read any science and technology book, everything starts with the R&D, which starts because of military requirement. Mostly 99%. Because every country, every nation wants to keep themselves one step ahead of other things. So technology is there. What is the difference between US, Europe and India and China? There is a technology gap, technology edges only. So that accordingly we need to develop capabilities and accordingly capacities in terms of scaling of it on this. This Atmanirbhar Bharat, it is a self-explanatory. The path to self-reliance. Basically, what are the simple steps? Design at home, manufacture at home, deploy at scale, and export globally. Why? Necessity it is there because you cannot rely on the foreign sources or some kind of proxies which will give you some solution, but they have different kind of controls. Validation is, of course, it is a core point as far as any successful system, indigenous system is concerned. Call to action: accelerate design of military grade sensors and AI chips. That is a domain where one can work. Lastly, very important line: self-reliance is a national security imperative. It is very, very important on this. And in the last, I told you, I'll give you some formal points which has got security, privacy and trust in IoT imperatives. You may like to note down, and I will give this copy to Professor Dimri also. So I start with first point is zero trust architect. As I mentioned to you, we are working in the electronics and telecommunication, dealing with the softwares and sensors and embedded these things. So first and foremost should be zero trust architect. It means ensure every TOT device, data packet and service is verified continuously. Second is zero knowledge proofs. Allows device to prove identity or data integrity without revealing sensitive informations. I am giving this point not only as a defense perspective, it for everything. If you design anything for the industry also, these things matters nowadays. Then hybrid PQC, that is a post-quantum cryptography that protects IoT devices from future quantum attacks and while remaining compatible today. Then hardware trojans. Next could be hardware biased AI. Then data poisoning, because attackers inject malicious data to manipulate IoT analytics or AI decisions. So these are the security facets. Once you work in this kind of IoT and sensors embedded systems and coupled with AI. So I'm sure with this kind of, though I have not covered any very research paper like though highly technical, but I'm sure the young generation here will carry away some points how this particular domain is very important and what are the role in you can say building of national capability and capacity in the time for technology fields and domains we have in this. I have finished on that. Any question from the young generation side? Not too technical, but anything you want to ask, any question. Thank you very much. Okay.
Sir, it is very nice to hear that IoT is war ready. That means the technology has proven its mettle.
Yeah.
I have if you could elaborate on this. What about this Kaveri engine? Where are we? Why can we make this indigenous thing, or we have to rely on GE? And because you are from mechanical engineering, so you could more well on.
Sir, I think last time also you have raised this question, but definitely I try to answer it.
That is also for the benefit of new engineers.
Yes. So you mentioned about this Kaveri engine. Yes, there is a gap as of now, but a lot of agencies are working on this. Especially like some of the DRDO labs, they have the particular focus to develop this kind of technology. Not only DRDO, but the kind of industry capability we have in India today, definitely we are going to address this issue. Main gaps are basically, I just mentioned to you, is a material domain. Because engine, that high precision, firstly machining, that kind of mechanical precisionness, and the kind of material you are using in those kind of integrated parts of the engines on that. So basically, the trend worldwide is to use composite materials, high-grade composite materials. Okay? Carbon-carbon composites, silicon-carbon composites. Those materials are used in various aerospace, you can say, industry, and some of them are used in this Kaveri type engines also. Like you must have heard last year, we had some kind of arrangement with the US government for transfer of technology for, I think, some G engine 414. That is again aerospace engine. So in that, I can tell you there are almost 30 to 40% components for composites. So those kind of technologies there. Yes, there are some gaps, especially the DRDO lab, the DRDO laboratory Jodhpur. They are dealing with this AMCA project, your advanced, your multi-role fighter jet programs, other things. They are working on the materials also, structural materials also, and Kaveri engines also, the components for this. Yes, there is, you can say, I can tell you, in my opinion, any prototype of Kaveri engine with the kind of things are happening now, okay, whether materials I have mentioned to you, yes, Indian agencies there to support, there are things, and electronics domains also, and machining also, happening also. 100% we can't do it because no country can have 100% solution. So what best of whatever indigenous, whatever say development we can do, it's happening as far as the Kaveri engine is concerned. And to my mind, in next 18 to 24 months, you will have first prototype ready for the Kaveri engine.
Thank you. And I would also like, sir, because DRDO has recently come up with the internship program. You have also said that with this thing. So our student would be greatly benefited if you tell them what are the career opportunity for engineers especially and how can they approach, so that will be a good thing.
Especially for this, anyone who is interested to join this defense research organizations like and Indian Space Research Organization, these and atomic energy as a professionals. There are various options depending upon your temperament, what kind of domain you are working, what kind of field engineering you are working, and your own interest. I can share, since I am part of this college, because till now the things must have changed during our time and recent past also. Here everybody tries to be part of industrial system, corporate system. So very, you can say, less percentage of students, they have got an ambition to join those kind of government entities right from the beginning. It may be lack of awareness or maybe type of environment this institution has because of industrial hub in Faridabad. So everybody wants to concentrate, okay, I'll get job here, I'll join this corporate, I'll do this, I'll start my own business. So that kind of culture each entity has got. Like IITs, different IITs have got different cultures, this college has a different culture. But I'm sure if anybody has got the temperament to join these kind of agencies, yes, you can join it. They have, each government agency has got their respective sites. Like DRDO has got a proper site, website. ISRO has got a proper website. Your Atomic Energy Commission has got a proper website. So it is directly in the Prime Minister's office. But each site will give you what kind of avenues, what kind of domain. DRDO has got all domains, all, you name anything, any domain of technology in world. It is there. It is your interest. You keep on, you have an eye on that. You keep on seeing whenever the opportunity comes, join them. And there is an opportunity which I shared with Professor Dimri and other colleagues of the college. There is an internship program by DRDO. Just go to the site, just see what it says. I don't know much about that. What is the system, how you can do that. Somebody shared with me, so I shared with that. So, nevertheless, it is a good opportunity, whether for anything comes from a space and the DRDO. Let me tell you, last 10 years, you must be hearing. I know, young mind, you have the different priorities that you're not aware of. But the next future is of space and the military research. There is a priority of the government also. That is the reason a lot of schemes government is coming up with this, your defense research incentives, these kind of things, R&D centers, hub centers, centralized, you can say, testing centers, everything is coming of that. And space, yes, that is there, because as on date, we have around 40-50 satellites. Can anybody guess how much China has got satellites? Any student? As on date? Anyone? Not exact number, just ballpark figure. Around 800. Okay. So it is not like we are not able to meet our requirement. Yes, we are addressing it, but there is a gap. So, to boost that, just to overcome that gap, what is the way ahead? Where is your private industries? As I mentioned to you, today the private industry has got a capacity and capability to fill up these gaps. And I just diverted from my topic. I was saying you can look for DRDOs, ISROs, and including some of the industries which are working in the defense domain. Whether working for the armament, missiles, or satellite domains, space domains, there are a lot of opportunities. But keep your eyes open. Every system has got websites, and this information keeps on coming. And I'm sure college must have some kind of, or in case it's not there, can create some kind of a cell, which whenever any opportunity comes up, that cell should put up those things or notice or some kind of WhatsApp group, whatever the faculties, whatever they say, mechanical faculty or electronics faculty, they can share among the students. But this thing has come up. Why don't you apply? Anybody can do that. And again, regarding this, joining of armed forces. I was part of this institution. At that time, it was not a like full-fledged engineering college. Even then, whatever the requirements were there, we did and joined the forces. Very, very less representation of YMCA. YMCA is there for almost last 50 years. But hardly I can count on my fingertips. There are only 10 to 12 officers who have joined armed forces. I must tell you, as a technology background, as a professional, you have a very, very promising career. Very, very promising career. Okay? If your aim is to live honorable life, to contribute for the country, you must join the DRDO, armed forces, okay, other government departments, do that. There are a lot of things to contribute. Lots and lots of things are contributed. Like Chairman DRDO present, he is not a chairman picked up from anywhere. He has come from the grassroots. He joined like an intern earlier. Then he becomes the scientist, then gradually, depending on his merit and whatever contribution is done, he is the chairman of DRDO. Similarly, all youngsters have got an energy. You must select your area, domain, go with the passion. If you want to join a particular system, I am sure you can do it. I can share my personal example. Right from the college days, I want to join the armed forces. So that was only my passion. Immediately, while I was in final year, I got selected for the escorts, as a campus interview. That time escorts used to be a very, very big dream. Almost 40 years, very, very big dream. But even then, I said, no, that is not my aim. I want to join armed forces. I am very happy, satisfied, whatever I could do. So, if you have this kind of any urge or any kind of your inclination, you must have a passion to achieve whatever you want to do that. You can do it. Thank you.
I am I.S. Oberoi, Chairman Institution of India.
Nice meeting you. Nice hearing, sir. Nice meeting you.
I came in between your lectures. Were wonderful hearing you. And like you mentioned to the students that Defense Forces and ISRO and DRDO, they are the wonderful grounds where the minds can be polished for Indian security. In fact, it's a pleasure for me for the audience also to inform that Institute of Engineers, we've been given AMI, and our alumni is currently ISRO chairman. So that's a proud moment for Institute of Engineers India. Yesterday, we had the state-of-art lecture from Dr. Narayan. And in that, he had mentioned some facial recognition warfare using small bots. And it was a scary kind of situation which he picked. And he said that this is the kind of warfare now people are planning. It's not at the moment there. So how do you think a country, a diverse country like India, can actually use IoT and AI to actually camouflage their kind of advances? because we have our own share of enemies and we can't change those perceptions which are there. And the conventional warfare is definitely going towards IoT and AI. So, do you are master in this trade and also defense, you've been very much involved in it. So I just wanted to know for a layman like us, that how a country like India with a diverse demography and not so knowledgeable, how can we protect ourselves, or how can the establishment, the defense establishment, what are they taking care to take care of that? That's a small question.
Yeah, I take it like you are looking something like this facial recognition kind of technologies and how to counter those kind of things. Am I correct?
Yes.
You are right, sir. That kind of threat is there. That kind of things are evolving. And you must have heard some of the countries, especially in Japan and China, they have got some kind of grid. They got a census in their various cities and other locations, and where they can identify individual who's dot and what is the name, what is the thing which they belong to, just by having the fixed kind census, those kind of things. Yes, those kind of things can be used for the military parlance also and the security parlance. Yes, of course, for the large scale military use, it is not. I'm not contemplating that, but definitely for some kind of surgical, you can say selective kind of usage. Let's say, for example, I want to, for a mission, for a particular operation, most critical thing is his commander. If I can address his commander or I can neutralize his commander, then I achieve almost half of the battle is with me. So yes, these kind of things can be used to give us kind of facial data, which is available everywhere nowadays. Okay? We are part of media, we are part of gatherings, even whatever I am doing on my mobile, I am generating some kind of data. So that can be done. Like we have some term, you can say your twin concept nowadays, digitally twin. This is happening. Something like that. Because if you have some kind of data, so that supplements this kind of digital twin in this kind of software, that can definitely track you and identify you, those kind of sensors, and can be used. But to use in a mass scale, it is slightly difficult. Not as a military scale, but yes, for a destabilizing scale, some kind of, you want to kill or neutralize some leader or something, some anybody, let's say, other way around also, some terrorist, some leader, it can be done. But just to counter this technology, yes, one of the DRDO lab is working on this. They are using like how basically how to in terms by using the same concept, how to, you can say, confuse this digital twin with kind of, when those system comes into this grid, their data and sensing is confused. That is the only way. So some of the lab is working, I can share with you. This much I know as of now. But yes, things are happening, but not matured at this level. And I'm sure time will come and these kind of things will be. First, we need to encounter such thing, we need to identify that threat and address that threat at the beginning only. That is the best thing we can do as of now. So that is what I know, sir, on this. Thank you. Thank you, sir. Jai Hind, everyone.
Thank you so much, sir. I extend our heartfelt gratitude to our esteemed speaker, Brigadier Bharadwaj ji, for the delivering such a insightful and inspiring address. Your expert perspective on IoT sensor integrated system and their transformative role in shaping the next generation smart technology has truly enriched in this lecture. Your talk not only illuminated current advancement but also provided valuable direction for the future research, innovation and industry applications, especially the latest technology used in Operation Sindoor, which was so inspiring for the new generation. We sincerely appreciate the time, depth of knowledge and clarity of vision you shared with us today. Your contribution has a set of remarkable tone for the rest of the session and will undoubtedly motivate our community for the engineers, researchers and students. So now I would like to invite Professor Dimri sir to present a memento as a token of our deep appreciation for your insightful and inspiring keynote address. Professor Neelam madam also can join. Oberoi sir, you also can join. YP Singh ji, please join. We also present a small memento to our sincere gratitude to your exceptional leadership and guidance as a session chair. Professor Neelam Turk madam, your commitment has ensured the success of this session. Thank you everyone to be here. It was a great session. Thank you everyone.
Good morning everyone. I warmly welcome you all to the technical session 5 of day 2 at the National Conference on IoT and Sensor Embedded IoT Driving Smart Connectivity. I, Dr. Nisha Yadav, will be moderating this session. On behalf of the organizing committee, I extend a heartfelt welcome to all our distinguished guests, respected faculty members, researchers, participants for attending this session. Now, it is my honor to introduce the session chair for this session, Professor Sonia Bansal ma'am. Professor Sonia Bansal ma'am is a professor and chairperson of the Department of Physics at JC Bose University YMCA, where she also serves as a Director of Industrial Affairs. With over 19 years of academic and research experience, she specializes in nanomaterials, printed sensors, spectroscopy and advanced materials research. She has completed and supervised multiple funded projects extending rupees 1 crore, developed 40 MOOCs under SWAM initiative and delivered national EduSat lectures through the Vyas channel. Her scholarly contributions include numerous SCI publications, international presentations and book chapters with Elsewhere and ACS. Dr. Bansal has guided several PhD and postgraduate researchers and is a life member of prestigious scientific bodies. The organizing committee is honored to welcome her as session chair for the session. We welcome you, ma'am. To begin the session with a gesture of respect and goodwill, we would like to present a sapling to our session chair. I request Professor Dimri sir and engineers I.S. Oberoi sir to kindly come forward and present the sapling to Professor Sonia Bansal ma'am. Now, to begin the presentation, our first presenter is Ashish Niranjan and team with paper ID NCET 56 and topic Safe IoT, a smart analytics framework for early food spoilage detection in street vendor environments. Ashish Niranjan ji, please come forward. Till the time if second present is ready, then I would like to request Manish Kumar ji and team with paper ID NCET 30. His topic is electrospun nanofibrous platform for simultaneous bacterial remover and real-time detection of biological drugs. Manish Kumar ji, you can come forward. Okay. So you can please wait. I think should be here for NCET.
Good morning to the distinguished jury and fellow delegates. We are here to present Safe IoT, a smart analytics framework for early food spoilage detection. So let's start with the reality of Indian street food sector. This is an economic giant where over 500 million consumers are daily consuming from street food environment, and there is roughly around 8,000 crores of market around them. So here the problem statement we are going to talk here is the human sense of failure. That this brings us to the core problem. Currently the vendors are relying entirely on human sensors, their own sight and smell to check if food is safe. The critical flaw here is that method is reactive. By the time the vendor smells bad milk or bacterial load is already toxic, they are they could not properly guess what's going wrong. So here we analyze this problem using the design thinking skill, which is also EAST framework. We needed a solution that is easy enough for non-technical vendors and affordable enough to be attractive, and with a battery management system which can be low cost for street food vendors who can easily afford the system. So literature survey, existing IoT monitoring focused only on formal supply chains, basically focus on cold storage and market supply. There is no such system who can be part of street food vendors. So that's what our idea came. Low cost system with a already present system has only single parameters. We have infused multimodal system which we use the sensor which has 3 to 4 parameters which can be more efficient. Also we have used an ML system to be efficient with the results so that it will be useful for both vendors and the consumers as well. Talking about the research, existing IoT devices usually track only temperatures, but temperature alone does not tell about the chemical breakdown inside the food. Sometimes the food will be hot, but it may not be good enough to consume. And some lab grade electronic nozzles, like their projects are there, which are also expensive and not real time. So that's also where our project comes in. Over to Ashish.
So we propose Safe IoT. So we have two sensors, which is a BME and ESP32 microprocessor for working. We use multi-parameter readings. We take gas resistance, estimate CO2, temperature, humidity and pressure. We use ML model random forest for classifying the product as fresh, highly risk and spoilage risk. So our novelty here lies is early detection before 6 to 10 hours of spoilage. So this is our novelty, and we designed it for street vendors, so it will cost low cost. And it is hardware and code software design. So this is our system architecture. There we have 3 sensing layers, and first one includes feature extraction. We will take temperature, humidity, and mainly gas resistance as feature. And the second phase we have edge processing, which is we don't require internet or cloud for getting the machine learning run successfully. And on the result we will alert the customers whether it's risk, spoil risk, or it is fresh fees. So we had taken samples milk, paneer, curd, and etc. for our data set. In the sensing layer, we will extract the data through our sensor BME 680, which is 4-in-1 sensor, which takes all the environmental factors, and mainly it detects VOC, volatile organic compounds, through gas resistance. So if gas resistance decreases, we will come to a conclusion that something is happening inside the food. So in this slide, our main motto is ML. We use random forest to extract the clear results of fresh spoilage and spoiled food. So here is our design of our prototype, which will be very portable for street vendors, and it is low cost. So our product is multimodal. So it includes 4 parameters where we take all the 4 and extract the features and does the ML training. And we reach an accuracy of 97% for the spoilage detection through random forest. So this is our ML methodology, starting with data acquisition and feature extraction. So first we take the gas resistance feature, which is main for detecting our food spoilage through chemical gases releases, because temperature is not enough to tell that this food is spoiled or not. So we need chemical or biochemical substance to clarify whether this food is spoiled or not. And then we do pre-processing and filters, we remove noises and then give a clear data for ML model, so it can very fast and can do the processing. So these are the outputs we got. We tried different models for the machine learning. We tried SVM and random forest, as we need many factors to decide whether the food is spoiled or not. We choose random forest because it is way better than SVM. Mathematically it is very fast. And the other feature importance we got through the data set.
So here the feature extraction, as we said, there are 4 features that we take from the sensor, and gas resistant is our primary feature with 34%. The final output totally relies on the 34% gas resistance, because that has mostly VOC, which are volatile organic compounds, that plays a major role in the output of the system. And next comes the humidity and CO2 temperature, all contribute equally to the final output. this is per product accuracy. So milk, we are going with the 100% accuracy we get whether the milk is spoiled or not. Followed by paneer, curd, and koa sweet and rice. This also goes for other liquid foods and other solid food as well. But this is our data set contains. We took data from these foods and all. So as you can see the table, accuracy for milk is 100%. Samples we took around 96. And we did a virtual data set, semi-synthetic data sets also we combined with that for newer data sets as well. This is the final output. You can get temporal spoilage detection. The first 0 to 6 hours, the gas resistance is 500, which means the good food is fresh, and the graph goes down gradually. By the time it's more than 12 hours, it enters the red zone. It's also known as a highly spoilage risk. These are specifically for the data set we took from the food, that's paneer and milk and all. And next one is the time one, CO2 increase in the food. That also ends with the high spoilage data.
So I conclude this as our safe IoT is the best one among all the sensors, because there are three factors which decides. We not only take temperature, but we also take gas resistance as a feature to conclude whether it is spoiled or a fresh piece. So we are going through biochemically, so that one is good. And we use random forest plus edge processing. Edge processing, the street vendors does not need any internet access for checking whether the milk or the food is good or not. So this is our specific thing we made clear, and it brings digital India to unorganized sectors. It supports Make in India by offering indigenous and low-cost alternative to imported lab testers, and it empowers the Eat Right India mission by preventing foodborne illness at the source. We have achieved scientific accuracy in 2300 rupees device that protects both the vendor's livelihood and the public's health. And our system does not do any false detection. We have multiple factors to decide whether the food is spoiled or not. So zero false negative is our result. These are the reference we took for our sensor. This is our use case study. If our idea becomes a product, we will have a system like this. So the customer also could see whether the product is fresh or it is in a risk stage, which will enhance our public health. Thank you.
Yes, any queries?
Now we are open to any questions. Okay, thank you.
How many samples have you tested?
We tested 900. Yes.
And result, have you tested it from the agency also so that it can be calibrated that your results are okay? Like
We have compared with last data sets. So they previously have some data sets which is the threshold point and all. So we compared it, and with our data we old papers we thoroughly.
very good.
Okay, thank you so much. Ashish, thank you so much.
Thank you.
Now moving forward to the next presentation, Manish Kumarji and team with paper ID NCET 30.
So good morning to everyone. I am Dr. Manish Kumar. Today I will be talking about electrospoon nanofiber membranes. Hello. So good morning everyone. I am Dr. Manish Kumar. Today I will be talking about electrospoon nanofiber membranes. So how many of you remember about COVID time? Do you remember COVID time? Right. So what is your favorite tablet? What we used to took the tablets either paracetamol or ascorbic acid, vitamin C, right? Correct. So do you remember that what it affects on your body, vitamin C and ascorbic acid or paracetamol? So today we will be talking about on those things, and later on we will know the how we can fabricate the flexible sensors using the electrospoon membranes. So basically I have prepared these slides for the students purpose, but I think most of the students has gone now due to some exams and also something, right? So let's start. So first of all, introduction about the electrospoon nanofiber membranes. So how we can fabricate the membranes, what are the applications of these membranes, and how we can functionalize them. These membranes are very essential for if we are talking about flexible substrates. If we are having a sensors, whatever type of sensors, if you talk about maximum sensors to nowadays, we want some variable sensors or some kind of flexible sensors. So we can multifunctional sensors we need, right? And for that we need some substrate which used be easy to functionalize it or to use it multifunctional, right? So in this we have nanofiber membranes. This nanofiber membrane has been prepared by the electrospinning setup. As you, thank you. Hello.
Full the volume.
Hello. Okay. So we are having here electrospinning setup. In electrospinning setup we are having a simply one high voltage supply, and then we will be having a syringe pump. Very simple setup. We can prepare it in our laboratories at very low scale. And if you want, we can have indigenous prepared also by IIT Kanpur, e-screen. And we are having here high voltage supply. When you are having a polymer, whatever flexible substrate you want to make it, you will be having a conductive polymers, or you can have a non-conductive, piezoelectric, piezoresistive, different kind of polymers you are having. So here I have used piezoelectric polymers, PEN, polyacryl nitride. So in this we are having a polyacryl nitride solution. First we dissolve it into DMF, and then we have filled it in this syringe. We applied a high voltage supply. When you apply a high voltage supply here, this telecon formation will be there. This, when you push it, this polymer solution will come out and it will take a telecon formation. And when you increase the potential around 35 kilovolt, this polymer solution will come out and you will get this kind of structures. Right? These are the some scanning electron microscopic images of the polymer. These are having the diameter of around 100 to 200 nanometers. And these polymers, nanofibers, again you can modify it with the different filters. I have modified it with using alpha abitose-free iron oxide. So basically these nanofibers then I have used for the various applications. These nanofibers can be used for the purification of water. So whatever heavy metals you are having in water, you can remove those heavy metals. Here I have tested for the copper and lead, heavy metals. Then further these same nanofibers could be used for testing of the paracetamol and ascorbic acids. Here we have tested this for the paracetamol sensings. Then again these are having multiple applications. Here are some graphical abstracts of my research articles which have been published, and some of them are highlighted on the journal articles page also. So cover page also, some of them are having selected for that. So these same nanofibers are used for the making masks, So how we can functionalize these nanofibers for the biological samples? First we are having here the sensing layer. The sensing layer is made by these nanofiber membranes. Then we have to functionalize this nanofiber membrane for the binding sites. We have to create some binding sites on these nanofibers. So these nanofibers can be treated with some chemicals and we can create the active binding sites on these for the particular applications. So different binding sites for the different applications. So these already I have discussed this electrospinning setup, and there are some various parameters. On which parameters the nanofiber range, diameter depends, and these mechanical properties also. They like strength. So solution parameters, if you increase the viscosity, the solution will be thick. And when you will make the fibers with the high viscosity material, then you will get the nanofibers with very high diameter, around 500 or maybe sometimes 1 micrometer. So when you increase the diameter area, or we can say surface area will reduce. When surface area will reduce, the sensitivity will go very low. So we need high surface area. In that case, we need low diameter of the fibers, right? So these are the some parameters on which the diameter depends of the nanofibers. So here I have tested it for paracetamol sensing and ascorbic acid, vitamin C. So here if you see this, we are having a 3 electrode working station. There we are having 3 electrodes. On one electrode GC, glassy carbon electrode, that will be your working electrode. Then you are having platinum, reference platinum, counter electrode, and then AgCl as a reference electrode. You will modify your working electrode with your material. Whatever material we have synthesized or we have modified that material you will deposit that material on the electrode, and that electrode will be used for the sensing applications. So here you are seeing 2 images. One is bare GC. When you are using bare GC, there will be 2 peaks. Redox reaction will be there, oxidation and reduction. So here you are having a oxidation peak and then reduction. When you coated this material on this your glassy carbon electrode, the peaks will go high, or you can say the current will change, both sides, oxidation and reduction. So in that case, it means that your working electrode is properly working, right? After that, you will add the different concentrations of paracetamol in your solution, electrolyte, and you can test it with the different change in the current when you are changing the molarity, or you can you are changing the concentration of your solution, then you are getting the different currents, right? So here you can find out the limit of detection or sensitivity for the this is for paracetamol, and same we go for DPV, differential pulse voltammetry, for the ascorbic acid. Similarly, these membranes are used for the E. coli bacteria and S. aureus bacteria. These bacteria here you can see, these are some dots are visible to you. These are the bacteria, E. coli bacteria. So after treatment, these all bacterial growth has been stopped. You can find out that bacterial growth can be stopped within around 12 hours. Similarly for S. aureus. So one of our project, this already has been tested and patented at IIT Hyderabad during my MTech time. So here we have tested this for the atrazine detection. Here you are having GC electrode and then modified it with the multi-hole carbon nanotubes. Further we have created binding sites using EDC, and then EDC, after EDC you are having a binding sites here. And these binding sites can be used for the antibody of atrazine detection. So these biceps, if you are looking, these are the antibodies for the atrazine. Then these remaining sites you can use for the BSA. So for to stop the interference study. So these are further various we have tested, and we finally prepared a model for this. So we are talking about the market size. In 2010, it was 1008 tons for the polymer, and it will grow about 27. It has been grown around 27.7 CAGR from 2016 to 2024. I think that's thank you. These are my collaborators which I have worked with them in different IITs during my MTech and PhD, and currently I am working in Sri Vishwanath University as an assistant professor. So thank you. If you are having any queries or questions, now you may ask.
Thank you, Manish ji. As we conclude this session, I extend my sincere thanks to our session chair for guiding the session so gracefully, and to all our speakers for their valuable contribution. Now, proceed to certificate distribution. I request Professor Sonia Bansal ma'am, Professor Dimbri sir and Engineer I.S. Oberoi sir to present the certificate to our participants. Ashish Niranjan, Ashish Niranjan ji and team. Next, Manish ji. Thank you so much, sir. Kindly remain here. Now, as a gesture of gratitude, we would like to present a memento and certificate to Professor Sonia Bansal ma'am for your valuable contribution. Thank you, ma'am. With this, we formally close this session. And I kindly invite all for the tea break. Venue. Sir, venue. tea के लिए.
तो बस सिर्फ हम 10 मिनट के लिए ब्रेक कर रहे हैं. देन वी विल अगेन ज्वाइन हियर. यू ऑल आर इनवाइटेड. प्लीज.